We're going to take a look at problems 16 through 19, dealing with impulse and the impulse momentum theorem. Number 16, a baseball, which has a mass of 0.14 kilograms, is pitched toward a waiting batter at a speed of 38 meters per second. The batter hits the ball back in the opposite direction with a speed of 58 meters per second. Because it's in the opposite direction, we're going to say that's negative. Since we're going to say the pitch direction is positive, the other direction back towards the pitcher is negative. We want to find the impulse applied to the ball by the bat. The impulse is change in momentum. So all we have to do is figure out, well, what is the change in momentum? Well, the momentum before the baseball was hit is just mass, 0.14 kilograms, times the speed, 38 meters per second, and we get 5.32 kilogram meters per second. We can find the momentum after it was hit. That's P prime is mass times the velocity after the hit, which is the mass, 0.14 kilograms, times the velocity, which is negative 58 meters per second. So the momentum after the hit is negative 8.12 kilogram meters per second. Change in momentum is simply the momentum after minus the momentum before. So we have negative, the negative is very important here, 8.12 kilogram meters per second minus 5.32 kilogram meters per second. And when we get that, we get negative 13.44 kilogram meters per second. And that direction is away from the batter. Number 17. Assuming that the bat in the previous question was in contact with the ball for 0.0016 seconds, we want to know the force exerted by the bat on the ball. Well, the change in momentum, or impulse, is equal to force multiplied by time. Since we're looking for the force, we can just divide our time over to the other side. We get delta P over time. That would be negative 13.44 kilogram meters per second, divided by the time, which is 0.0016 seconds. That's all going to give me the force, and that would be 8,400 newtons. It's negative because the force was away from the batter, so that was in the negative direction. Number 18, a hockey player makes a slap shot exerting a force of 30 newtons on a hockey puck for 0.16 seconds. What impulse is given to the puck? Well, impulse is force multiplied by time. We just have to multiply our two numbers. 30 newtons times 0.16 seconds gives me an impulse or change in momentum of 4.8 kilogram meters per second. Number 19. If the hockey puck in problem 18 there has a mass of 0.115 kilograms, and that mass is given right down in here, and was at rest before the shot, we're going to find the speed that it now has after being hit. So the change in momentum is momentum final minus initial momentum. We know the initial momentum is 0 because it wasn't moving. So that means the change in momentum is just how much momentum it has at the end of the problem, whatever P prime is. And that's just found easily by mass times the velocity after the hit. Well, we know what the change in momentum is. We solved for it in the previous question, the 4.8. So change in momentum divided by the mass is going to tell me how fast it's moving after the hit. So 4.8 kilogram meters per second, which was the change in momentum we solved in the previous problem, divided by the mass of 0.115 kilograms, and that's going to give me a speed of 41.7 meters per second.